Good evening, everyone. On behalf of Guru Nanak Institute of Technology, myself K. Deepika extend a very sincere warm welcome to all of you present in this session of guest lecture on fluid mechanics and hydraulic machines. It's my pleasure to introduce today's guest speaker, Dr. B.V. Raja Ravikumar, Professor, Vienna VJIT, Hyderabad. It is an honor and privilege for us to have you with us today, and I'm sure we will be enriched by the guest lecture. Once again, I welcome you, sir. Now I request Dr. B.V. Ravikumar, sir, to address the lecture. Once again, I welcome you, sir.
Thank you, madam. Thank you.
Thank you, sir.
Respected Professor M. Srihari and the Raghu and Deepika madam of Guru Nanak Institute of Technology, and my dear students, participants. Good evening to all. It is a great honor to me to invite me to give the guest lecture to the students. So today I am going to teach the fluid mechanics hydraulic machines subject, which is useful and very important subject to especially for mechanical engineering guys who are working in that power sectors. So today I am going to give that guest lecture. Please concentrate and listen, and you can make that lecture to be best for your career in this future. Thank you. Shall I start, sir? Can present share mode. You can have the share mode.
Sir, I shared one poster now, sir. Please share that, sir. We will take one pic.
Which one you want, sir?
Before that, sir, I send you, sir, your poster.
Yes, yeah.
Poster, that one.
Yes.
After that, you can go. Yes.
Right, sir?
Yes, this one, sir. One moment, sir. I'll take one pic.
Okay, myself is Dr. B.V. Ravikumar, is a professor of Department of Mechanical Engineering, VNR Vijnana Institute of Engineering and Technology, Vachapalli, Hyderabad. It's over, sir?
Yes, sir. It's over, sir. Then you can take your.
Okay. Is it visible, sir? Slide?
Yes, it is visible, sir. Slide is visible.
Okay. I can put into this
complete screen, sir. Full screen.
Full screen, yes. Yeah, fluid mechanics hydraulic machines. Am I audible?
Yes, audible, sir.
Yeah, fluid is a substance which deforms continuously or flows when subject to the shear forces. Actually, a fluid is a substance which deforms continuously under the action of the shear force. It doesn't have any particular shape. It can be formed according to the shape of the vessel, and it can be continuously deformed under the action of the shear stress or shear force. Actually, it is in the form of a fluid, is in the form of a layers. The stress is the stress which is occurred between the two layers is called as the shear stress. You know the different types of stress are there: tensile stress, compressive stress, and shear stress. Actually, these three stresses are occurred in the solid mechanics, but in case of the fluid mechanics, you have only one stress is called as the shear stress. Coming to the solid mechanics, you can the solid is having a different shape. You can able to measure the dimensions of all these solid particles. So accordingly, you can if the force is acting on the solid, it is a tensile nature. That means equal magnetic force acting in opposite directions. The stress induced in the material is called as a tensile stress. Otherwise, it is in a compressive nature. You can get this a compressive stress. It is the rubbing that each other is called as the shear stress. But in case of the fluids, it doesn't have any shape. It is in the form of a layers. The stress which is occurred between these layers is called as a shear force. The fluid can't resist the deformation of the force. It moves, it flows under the action of the forces. So it can be moved in any direction under the action of the forces in which direction it has to be action. You can't say that a fluid is moving in the one direction. It may be move in the X direction, it may move in the Y direction, it may move in the Z direction. That's why you can be consideration of all these ways and then come into the, suppose you want to be calculate the acceleration of the fluid in the X direction. That means see AX. That is in the AX means that is in the direction of the X. So the velocity of the fluid body in the direction of the X is called as the U. You can be mentioned that. So if you want to calculate the AX value, then you can be take the consideration of all these direction of the force in the other X also. That is the Y axis and Z axis also. So like that, the fluid is you can't say that which is moving in this direction only. So deformation is caused by the shear force and which is act tangentially to the surface. So the fluid is ultimately the definition of the fluid is the substance which deforms continuously or flow when subject to the shear force. Actually, the fluid mechanics, the fluids is the two types of fluids. One is the liquid fluids, other one is the gaseous fluids. The study of behavior of the liquid fluid is called as the hydraulics, and study of behavior of the gaseous fluid is called as the pneumatics. Now our subject is the fluid mechanics and hydraulic machines. Now we can be concentrated more on the fluid mechanics. So you can say the here can ABCD is the fluid element. The force is acting tangentially acting on the ABCD. So this is the shear force and produce the, you can say, and because of this intensity of the force F which is acting on the AB, the A can be deformed to A dash and B can be deformed to B dash. So A dash, B dash, D and C is in the new formation of the fluid element subject to the F. So deformation is caused by the shear forces which act tangentially to a surface. So we can see the force F acting tangentially on the rectangle element ABCD. This is the shear force and produce the dashed line ABC, A dash and B dash, and then A dash, B dash and D and C is in the rhombus flow. So the fluid is substance which deforms continuously or flows when subject to the shear forces. So you can see it is in the form of layers. You can say this is the fluid layer 1, layer 2, layer 3 and row. So these are the shear force acting on that. So F1, F2, F3. It is in the form of layers. This is the called as a one plate you can take, and this is the bottom of the fluid is here, one layer, second layer, and in between is the shear force is acting in between. So because of the shear force acting, it is to be moving on that. Uppermost layer is having the tangential velocity. So another one is to be, you can see at this. So that is called as a velocity of the flow in the channel. Once it is to be hit on that, it's called as a solid body is to be placed here, which is against the flow of the water in the speed stream velocity u. So it is called as a leading edge. And when the leading edge is whenever the fluid is touched at the leading edge, it can be deformed like this. So it is in the form of these different layers are called. It is called as a boundary layer concept. It is called laminar boundary layer, transition, and turbulent boundary layer. You can discuss in the future slides. So the fluid may be defined as a substance when deforms continuously under the action of the shear stress regardless of its magnitude. And the fluid mechanics, our subject is the fluid mechanics and hydraulic machines. It is in fact, it is two parts: fluid mechanics and hydraulic machines. The fluid mechanics says that is the fundamentals of this fluid mechanics. Fundamentals of subject is called as a fluid mechanics. Application of these fundamentals is called as the hydraulic machines. So fluid mechanics is the branch of science which deals with the study of the behavior of the fluids at rest as well as in the motion. So at rest of you can study the fluid behavior at rest is called as the statics. That's what fluid statics. If it is a study of the fluid is in motion, it's called as the kinematics and dynamics. Actually, there is a fluid mechanics is covers the fluid statics, fluid kinematics, and fluid dynamics. So what the fluid statics is says that the study of behavior of the fluid at rest, without motion of the fluid, it will be stay at the resting position. Then you can say there's the subject is called the fluid statics. In the fluid statics, what you have to study is the fluid properties and the fluid pressure, measurement of the fluid pressure, or how the formation of the fluid pressure, and total pressure, center of pressure, and submerged behavior of the submerged bodies, and find out the total pressure of the submerged body. There is in 4 conditions: the vertical submerged body, horizontal plane surface, vertical plane surface, and then curved plane surface. So inclined plane surface. There are different types of cases you can be studied. So in this particular cases, the fluid never be moving. Such a particular subject is called as a fluid at rest, is called as statics. In motion is called as a kinematics. The study of fluid mechanics deals with the study of the motion of the fluid is called as a kinematics. So without kinematics means without consideration of the force acting on it. there is no pressure force acting on the fluid while it is moving from one place to another place. Such a subject is called as a fluid kinematics. And the fluid kinematics means what you have to be study is the classification of the flows and flow lines. Classification of flows means steady, unsteady flow, uniform, non-uniform flow, laminar, turbulent flow, and compressed and compressed flow. There are different types of flows is classified based on the nature. Then the study is called as a kinematics. In the kinematics flow, you can also be get the one equation, the continued equation of flow. Q is equal to A1 V1 for one dimensional, for three dimensional flow can be studied. That is called as a fluid kinematics. Another one is a fluid dynamics. Fluid dynamics is the branch of fluid mechanics. It deals with the study of the behavior of the fluid while it is subject to the certain amount of the forces. So it is designated as a Newton's second law of motion. So according to that, certain forces are acting on the fluid mass. There is pressure force, gravity force, viscous force, turbulent force, surface tension force. There are different types of forces are acting on the fluid mass. Then the study of the behavior of the fluid mass is called as a fluid dynamics. So the fluid mechanics is the branch of engineering science. It deals with the study of the study of the fluid at rest or in motion. And the rest condition is the statics. In motion is the motion of the fluid is created two. One is the without forces and with forces. Without forces, the study of the motion of the fluid is the kinematics, and with the application of the force is called as dynamics. That means, for example, is the water stored in the reservoirs is called as the statics. The water flowing in the rivers or reservoir in the channels is called as a fluid kinematics, and the water is moving in the centrifugal pumps or certain whirlpool or example of the dynamics. So you have to apply this at the force. So that all these things are come into the fluid mechanics. Another application of this fluid mechanics is called as the hydraulic machines. Am I audible?
Yes, sir.
Yeah. Hydraulic machines are devices which converts hydraulic energy into mechanical energy, or vice versa. Mechanical energy into hydraulic energy is called as hydraulic machines. The hydraulic machines are the devices which converts the hydraulic energy into mechanical energy. That's called as the turbines. Mechanical into hydraulic energy is called as the pumps. There are the two types of machines you are going to be study. One is the turbine, second is the pump. So you can be observe it is the turbines. You can observe this small diagram. For that you can say impact of jet. Jet is come out from this nozzle, it is on the blade, and the turbine will be rotated. It is an example of this hydraulic turbine. It is a popularly it is called as a Pelton wheel. Another one is another turbine is called as a hydraulic reaction turbine. That's called a fancy. Just you can observe this diagram. It's a video, small video. The water which is come out from the reservoir. The water will be going through this. This is called as a Francis turbine. Both are the example of these turbines. One is the Pelton wheel. This is called as the impulse turbine. Another one is called as the reaction turbine. This is called as Francis turbine. So these are the guidewire mechanism is there. Certain mechanism is inside that. So it will be. It is both are the example for the hydraulic turbines. Then the outputs of the turbine is connected to the generator. The generator supplies the power. That power is distributed to that networking system. So both are the example for the hydraulic turbines. So this is called as a Francis turbine. You can call this called as a Pelton wheel and tile race. From the tile race, you can go for this one. Another one is the pumps. There are two types of pumps are there. One is the centrifugal pump, other one is the reciprocating pump. Both are the example of the pumps. You can say the important part of the pump is called as the impeller. Impeller is rotating. Because of rotation of the impeller, the water will be enter into the vacuum. Partial vacuum is created inside the pump. Then it will be rotated due to the centrifugal force. The pressure of the fluid will be increased, and then it reaches once it is reached to the desired pressure, that will be placed into this. Another one is the reciprocating pump. Due to the reciprocating action of the piston in the cylinder with the help of the connecting rod and shank, then the partial vacuum is created, and that section valve will be opened. The water will be entered into the cylinder, and then once the forward in this backward stroke, in the forward stroke, the amount of the water is stayed in that compressed. First will be acting on that water, pressure of the water will be increased, and then reach to the, once it is delivery valve open, and then we reach to the discharge pipe. So so these two are the example of the hydraulic pumps, and the previous one is both are the example of the hydraulic turbines. So these both are the combination is called as hydraulic machines. The fluid mechanics, fundamentals of these fluid mechanics is applied to this machinery, that's called as hydraulic. So the subject is to be two subjects. One is the fluid mechanics, second one is the hydraulic machines. So now, due to the time constraint, in this today's lecture, I want to cover the only fluid mechanics part in briefly for your better understanding. So if you find that the time in the next time, then I will try to cover the hydraulic machines. So fluid mechanics, all I told you, fluid mechanics is a branch of engineering mechanics. The branch of fluid mechanics deals fluid mechanics is the branch of engineering science, deals with the study of the fluid at rest as well as in the motion. These are the two types. One is the statics, kinematics, and dynamics. So static is the study of fluid at rest is called statics. A study of behavior of the fluid at motion without consideration of pressure force is called as the kinematics. The study of behavior of the fluid at the motion with the consideration of pressure force is called as the dynamics. So the importance of the fluid mechanics: design of the wide range of hydraulic structures, dams, canals, channels, etc. So the knowledge of the subject is very much essential for the civil engineering people to construct on the dams. In the dams or reservoirs is the water storage. Once the water is stored in that amount of the water is to be creating the static pressure on the walls of the canals and dams. So according to that pressure, then you can be how much the pressure is to be generated, how much the pressure force is developed by the water stored in the reservoir or dams. Accordingly, you can be construct the dam. And design of the complex networks of the pumping and the pipelines for transporting liquids, flow of water through the pipes and its distribution, domestic service lines, the networking of the pipes. In the pipe networking of the pipes means in the pipe, whenever the water is flowing in the pipe, there are the two types of energy loss are occurred in that. Already you studied that. One is the major losses, second one is the minor losses. So due to the frictional forces, the losses incurred in the pipe flow is called as a major loss. So according to Darcy's equation, you can able to find out head loss due to friction HF is equal to 4F viscous 2ZD. Another loss is the minor losses. Minor losses occurred because of these because of pipe fittings, like energy loss at entry of the pipe and exit of the pipeline, and sudden contraction, sudden expansion, pipe fittings. All these things are be producing the minor losses. So there are two types of loss incurred. That's one. So knowledge of this subject is essential to calculating the different types of losses. So compared to these two losses, major losses are very, very high compared to that other one. So many times, mostly the minor losses occurred in the pipelines is neglected. Another one is the networking of the pipelines. That means a compound pipeline, parallel pipeline. Compound pipeline means the different pipes, the pipes having the different lengths and diameters connected end to end in series connection. That's called as a compound pipe. Parallel pipe means the single pipe is divided to branch pipes like a parallel pipe. So these are the two piping networks. Another one is the equivalent pipe. The equivalent pipe is used in place of the compound pipe. Suppose if you want to keep that one single pipe instead of in the place of the compound pipe, then you can find out the one equation. L by d power 5 is equal to L1 by d1 to the power 5 plus L2 by d2 to the power 5 plus L3 by d3 to the power, and so on. That equation is called Dupes equation. So this equation is helpful to find the length and diameter of the compound of the equivalent pipe, which is to be going to be replaced in the compound pipe. So for the design of the piping network, this subject knowledge is very much important. In the particular cases, you can use the Darcy's equation and also the Carnot equation. Another one is the fluid control devices. That's called hydraulic and pneumatic devices. This fluid control devices means direction control valve, flow control valve, and pressure control valve. There are three types of control valves are used in the hydraulic pneumatic circuits. There is a for automation purpose. You can be nowadays you can use that hydraulic and pneumatic operations. So we suppose like JCB operation, there is a hydraulic components. Hydraulic operation is there. So hydraulic components have plays the major role in the engineering applications to lifting of the heavy loads or carrying the works, all these things. So the design of the control valves, this knowledge is very much important. Another one is the methods and devices of the measurement of various parameters like a pressure and velocity of the fluid at rest or motion. The pressure measuring devices or velocity measuring devices. Pressure measuring devices, manometers are the mostly used for pressure measurement devices. So you can use the simple manometer and differential manometer. You can use for the principle is there, applying the principle to be balancing of the column principle is involved in the manometers. Then according to that, you can find out the pressure of the fluid at anywhere. And velocity of the, you can use the petata tube. From the petata tube, you can be used for the velocity of the flow. Power generation for conventional such as hydroelectric, steam, and gas conversion. So all these things is the knowledge of the subject is very important. This called as the importance of the fluid mechanics. Another one, application of the fluid mechanics. So the pressure measurement and flow measurement, stability of the dam, energy conversion, drag and lift, boundary layer, and its applicable. These are all these things is the mechanics of fluid plays the major role. The pressure measurement. So you can be using the manometers. Manometers device used to find the pressure of the fluid at a particular point in the flowing pipe, or difference of the fluid pressure at two different points. So if the fluid is flowing in the two different pipelines, with the help of the differential manometer, you can able to find out. And the flow measuring devices, venturimeter or phase meter, both are the flow measuring devices. You can, with the help of that devices, you can able to find the flow measurement. So phase meter, the venturimeter. Venturimeter is some construction device is there on the construction. You can be find out the discharge. A1, A2 root 2 GH by square root of A1 square minus A2 square. So different formulas are there. A1 is the construction of the pipeline, A2 is the construction of the throat, and H is the manometer height. And these things has to find out. So then you can able to find out the discharge. Suppose you want to find the discharge of the any portion of the lengthy pipeline, you can use the instrument. Such instrument is called as a flow measuring instrument. That is called as, best example is the venturimeter. Stability of the dam, all I told you that is the water is to be stored here. What is to be stored here. So it will be the this is in the static condition. The entire the pressure will be acting on the wall of the dam. So then you can be calculate that how much the load is acting on it, how much the total pressure acting on the wall dam. You can able to find out certain equations are there. On the equations you can able to be find. And energy conversion is the pumps and turbines. All I told you that turbines and pumps which are used for the pump conversion, energy conversion. So one hydraulic energy into mechanical is called turbines. Mechanical energy into hydraulic energy is called as a pump. And drag and lift. So drag force and lift force is both are the aerodynamic system. So this concept is to be applicable in the aerospace designs. Another the boundary layer. So whenever it is called as a flow, water is flowing with the mainstream velocity u, it will be hit at the leading edge, and it will be taken like this a jump. That's called as a boundary layer. You can see the three types of boundary layers is called. It's called a laminar boundary layer. All these fluids are moving in the well-defined path. Is a transition and is a turbulent. So these are the applications of the fluid mechanics. And then fluid mechanics is that into today's class we are going to be discussed into four topics I had to cover. Fluid statics. The fluid statics had to cover the fluid properties, pressure and its measurement of pressure on submerged bodies. Another is the fluid kinematics, types of flows and lines and continuity equation. And fluid dynamics portion, forces acting on the fluid mass, Bernoulli's equation and its applications. And the boundary layer theory, concept of the boundary layer. So these are the briefly I would try to cover these topics in one by one. So due to the time constraint, I had given the briefing about this subject for better understanding. So fluid statics. So what topics I am going to cover is the properties, fluid properties, pressure and its measurements, pressure on submerged bodies. So the important properties of fluid is the density, specific weight, specific gravity, and viscosity. Density of the fluid is the mass per unit volume, that is called kg per meter cube, is the density. It is represented with the rho, and the density of the water is the 1000 kg per meter cube. A specific weight is to be a specific weight of the specific defined as the density of the fluid to the density of the weight by volume. Weight by volume is called as a specific weight, that is represented with the W. W is equal to, after simplification, W is equal to rho into G. Rho is the density of the water, G is acceleration due to gravity. W is equal to rho into G. Rho is 1000, G 9.81. Then 9810 is the specific weight of the water. Specific weight of the water is 9810 Newton per meter cube is the specific weight of the water. Suppose you want to find the weight of the water. So specific weight of the water into volume of the container. Then you can put a multiplication of this one. You can get it in. Suppose specific you want to find the specific weight of the some oil. That is the specific weight of the water into specific weight of the water. You can get it is the specific weight of the particular oil is or density water it may be. And specific gravity is defined as the specific weight of the fluid or density of the fluid to the density of the standard fluid is called as specific gravity. The specific gravity definition is density of the fluid to the density of the standard fluid. Okay. Density of specific gravity of the, what is the specific gravity of the standard fluid is the water. Water is the standard fluid. So specific gravity of the water is equal to 1 by 1, that is equal to specific gravity, density of the water by density of this one is called, both of the cancel, then you can get the